So let's do one problem where we use the mean deviation method, finding the mean by deviation method. So I have taken the following score where I have to find mean by deviation method, and the score here is the data 7, 10, 15, 21 and 27. So as we know that the deviation method has the formula with its mean calculated as a plus sigma I equal to 1 to n xi minus a whole by n. I'm going to find the mean by deviation method by first assuming the mean. So we need to first go through the assumed mean. As we also discussed that assumed mean is expressed in three different ways. So let me take the assumed mean as max plus min by 2 and calculate for its mean by deviation method. So if I take the assumed mean a as max plus min by 2, where the max is this and the min is this, then I get max plus min by 2, which would give me the assumed mean as 17. So let me calculate using a as 17. Now the assumed mean is, in this case of a problem, is calculated with max plus min by 2, which gave me 17. So using this assumed mean and using this formula, firstly I'll try to initially calculate xi minus a, where the xi is each of the score as given in the first column, 7, 10, 15, 21, 27, totally 5 observations out here. So with this, my xi minus a would give me each of the observations with subtracted with 17. So here I get 7 minus 17, which would give me negative 10, then 10 minus 17, which would give me negative 3, and 15 minus 17, which would give me negative 2, and 21 minus 17, which gives me 4, and 27 minus 17, which gives me the value as 10. So this is how I calculate the the xi minus a for each of the observations. Then immediately I need to calculate the number of observations, which I know is clearly 1, 2, 3, 4, 5. So the total number of observations is 5. Therefore n is equal to 5. And I have my a is 17, from where I calculated each of the deviation. So using this formula, then I get the solution process for finding the mean by deviation method. Now here we got the assumed mean with 17, and for each of the score, the assumed mean when subtracted from the score gives me this column. Now here with the formula, I need to find sigma xi minus a. So this I would be doing by calculating each of the score starting from 7 to 27. So when I add, I just get this as 10, 14 minus 15, which is negative 1. So my deviation is negative 1 with subtraction of each score. Therefore, using all the values in substituting in the formula, my mean by deviation method, which goes with the formula a plus sigma I is equal to 1 to n of xi minus a by n, would proceed with the formula 17 plus sigma I running from 1 to 5 of xi minus 17 by 5, which is directly calculated from here as negative 1 over 5. So which on simplification gives me 17 minus 1 by 5, which is nothing but 17 minus 1 by 5 is 0.2. So this would give me 16.8 approximately. So my mean by the deviation method would just give me the value as 16.8 using the assumed mean, which is assumed as 17. So an assumed mean, which is assumed with the max plus min by 2, or the middle value of the data, or sometimes with finding the average or the mean, can help us in identifying the assumed mean and then using that for calculating the mean by deviation method. Sometimes the problems itself give the value of the assumed mean, and that is the assumed mean which we take for a and simplify with the same process. But ultimately, mean by deviation method is done by taking the score and then next with xi minus a with assumed mean calculated in its respective manner by each of the individual methods, and then subtracting each of the score from there, then add up will give me sigma of xi minus a with I running from 1 to n being the number of observations. Then from that, the formula which is already derived for mean by standard deviation by the deviation method gives me a plus sigma I equal to 1 to n xi minus a by n, in which each of the content values are substituted, which on simplification gives me the value of mean, which is calculated by deviation method. So this is how we do the mean by deviation method. Now that we have seen the mean by various methods, finding the mean by average process and finding the mean by deviation method, the next measure of central tendency which we have discussed is about median. So how to calculate the median? So median is identified as the middle value of the entire data. So however large the data is, the middle value of that given data is said to be the median. So it's very simple in understanding with its definition. Median is the middle value of the entire data. So it is assumed that the middle value controls the entire data. Therefore, because of the equal number of data on the left, on the right, the middle value is also assumed to control, has the tendency to control the entire data. So hence it is a kind of a measure of central tendency, the median. So it is the middle value of the data. So for example, if I take the data as 3, 5, 7, 4, 1, 2, 6. Now the first and foremost thing in median is when you want to calculate the median, you have to identify the data in a sequential order. Either it should be an ascending order or it should be in the descending order. The data starting from lowest to highest or highest to lowest. So putting the data in order is very important before we calculate the median, or else the whole of the value obtained through the middle value concept would be wrong. So for the given example, which has the observations starting from 3, 5, 7, 4, 1, 2, 6, I would like to arrange this data in a chronological order. So for this, if I wanted to calculate the median, I start with the lowest value to the highest value, that is in ascending order. So when I go with the ascending order, my first value is 1, 2, 3, 4, 5, 6, 7. I have all the values, the integers from 1 to 7. So in this case, I identify the middle value by just cancelling the first and last, then the second last and the second, and this, then whatever is left in the middle is the middle value, and hence the median by the definition which says it's the middle value. Therefore, this is called the median, the middle value. So hence here the median is 4. So for any data, we just assume the median through writing in the chronological order and then identifying the middle value. But now the question arises, what if there are two middle values in the entire data? So how do you calculate the median when you have two middle values for the even number of data? Of course, for odd number of data, you have only one middle value, but if you take the even number of data, you have two middle values, then the median would be the average of those two middle values identified in case of the given observations. Now, the third measure of central tendency is mode. Already discussed with mean and median. So the third measure of central tendency, the mode, which we're going to discuss in this session. So as we had the basic definitions of mean and median, also equally mode has its own definition. So let's see what is the definition of a mode. Mode is the most recurring observation for the data. So whichever observation is said to be most recurring is said to be the mode. Say for example, I have now in this case there are different observations. Totally I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 observations, starting with 1, 1, 2, 3, 1, 4, 4, 4, 5, 1, 3, 1, 2, 1. So with these observations, I wanted to know which is the most recurring value out of the entire data. So let me take with 1. I clearly find that with the outer picture of the data, I clearly identify that 1 is most occurring out here. It appears mostly. Let's see how many times does 1 repeat. 1, 2, 3, 4, 5, 6. So 1 repeats 6 times. And let's also see 4, because I identify 4 a couple of times. But as I see, 4 repeats 3 times. And also 3 repeats 2 times. So obviously the highest or the most recurring element in case of all the observations here is 1, which is nothing but mode, according to the definition. The definition says that mode is the most recurring observation for the given data. In case of an example where it is considered with this data, mode is nothing but here. Mode is nothing but 1, because this is the most recurring value of the observation. Therefore, mode is 1. So for any observation, the most recurring value is nothing but the mode. So we have seen 3 basic definitions, but here, if suppose, just like in median, if we have a tie, if there are 2 values which have the same number of repetitions, then in that case, the data is called bimodal data, or we have 2 modes for the given problem. So we take both of them to be the modes for the same data. Say for example, if I have the data 5, 4, 4, 3, 5, 5, 6, 7, 3, 3. So here I clearly identify that if you just take the number of threes which you have, here, they are in number 1, 2 and 3. So there are 3 times that a 3 is repeated. But equally, I also observe that if I take the 4, it is repeated 2 times. But you take the 5, it is repeated also 3 times. So the value 3 repeats 3 times and the value 5 also repeats 3 times. Therefore, the most recurring observation or the most recurring value of the data which we identify here is 3 times, which is the value 3 and 5. So there are 2 values which recur most number of times. Therefore, mode of the given data is said to be both 3 and 5. So mode of the data is 3 and also 5. And this kind of an observation is called bimodal data because it has 2 data. So this kind of a data is called bimodal data simply because it has 2 particular data, 3 and 5. The mode, it has 2 particular modes, one being 3 and one being 5, and hence called a bimodal data. Now that the measures of central tendency has come to an end with each of its definition as discussed in each of the session, the mean, median and mode. The mean, median and mode, when taken in the learning outcome, finally we understand the learning outcome of mean, median and mode is that the mean always depends on n. The number of data will change the value of mean. If suppose I add one more data to already existing data, then definitely the mean changes because its average would have one more observation added to its numerator in addition of each of the observation. Similarly, The number of observation also affects the median, because if the number of data is included in addition to the existing data, then it can make the data even or odd, and then the middle value changes according to the number of data increasing accordingly. So the number of data is very much depending on the median, or median depends on n, the number of observations, simply because the middle value changes with addition or removal of some of the data. Similarly, when we take the mode, the does not depend on n. The mode doesn't depend on n, because if the most recurring element is what is counted in the number of data, but we don't include the existence of as many data as included, provided the mode is calculated on the basis of the definition, which says that the most recurring element is the mode. So this is how we understand between mean, median and mode. And when we go through the median, also the median doesn't depend on the extreme values. It is only the middle value which is identified. So the median is irrespective of the extremes, the extreme values on the right and left. But when you take the mean, each of the observation is considered to be important, because mean is calculated from each of the observation added divided by n. So finally, we make the comparison between mean, median and mode simply with their respective definitions, and that is how we understand the three measures of central tendency: mean, median and mode. So now that we have discussed about the data and the three measures of central tendency, now we will go into more modifying of the data, which is called group data. So sometimes we don't take the individual data, but we take the group data. Say for example, if we wanted to find if in a school we have more number of students, say we have 500 students in the school, and I wanted to know if first 50 students, what is the score, average score of the students, and the next 100 to 200 students, what is the average of their score, and the next 300 to 400 students, what is the average of their score in the group. So I'm trying to divide all the students group wise. So the group wise division of the students will help me in understanding the average score of each group wise. So identifying the score of the student through each and every individual may not be an easy task. Therefore, we group them, and hence group data is sometimes also very important. Say for example, I wanted to group the data of, usually the grouping is done by taking in the column wise form. So we just take it in this way. So in this case, if suppose I say my group is called class interval, this will give me the understanding that what is the range of each class or the group. So let me say 1 to 10 students have their heights which range from 5 to 5 feet. So let me say this is the frequency. 5 students have passed from the group of 1 to 10, roll number 1 to 10. So let's take it that as an example. So from roll number 1 to 10, there are 5 students who have passed. The remaining 5 have not passed. So next I take from 11 to 20. The roll number from 11 to 20, only 7 students have passed. In this case of roll number 11 to 20. Next I have 21 to 30. In this case of the roll number starting from 21 and ending with 30, I have 4 students who have passed. So in this case, next I have 31 to 40. The roll number 31 to 40, there are 3 students who have passed. So frequency makes me understand the number of students or the number of observations, which is usually called as frequency. So in this case, being that with an example which I have considered, the roll number 1 to 10, only 5 students have passed out of the students with the roll numbers 1 to 10. Then with the roll number 11 to 20, there are only 7 students who have passed. And then I understand that with this table which says 21 to 30, there are only 4 students who have passed. Then 31 to 40, only 3 students who have passed. So this gives me the picture of a group data given in tabular form. So generally the group data is considered in the tabular form with the first column with class interval and the second column with the frequency, which describes the class interval or the group considered in the first column. So that is how we take the grouped data, this being one of the example. Now the next concept which comes is, what is the limit or a boundary of the given class interval? It is very important because sometimes the problems solely depend on the limits or boundaries of the given class interval. So let's also define limit or boundary for the given problem directly. So let's come to finding the limits for the same problem. So considering the similar example here, my first class interval starts with 1 and ends with 10. That means the limit of the first group is starting with roll number 1 and ending with 10. So my limit is from 1 to 10. So usually my lower limit is taken on the value which is on the left and my upper limit is taken for the value which is on the right. So for here, all these count under lower limits and all this count under upper limits. Therefore, there are two types of limits. One is the lower limit and the next is the upper limit. So each of the range will have the lowest value which is considered as the lower limit and the highest value which is considered as the upper limit. In each of the group case where 1, 11, 21 and 31 are the lower limits and 10, 20, 30 and 40 are the upper limits. So in case of the given example problem where the class interval range is given, my lower limits are 1, 11, 21 and 30 and upper limits are 10, 20, 30 and 40. So this is how I identify the limits of the given group data given in the column wise class interval representation. Now we'll try to define the boundaries. What are the boundaries for the given limits? So this is also very important because we have to understand the difference between limits and boundaries, because limits have their own definition and boundaries are modified limits, because sometimes we need to modify the limits to come to the boundaries or make the conclusion for boundaries. So let's also see what are the boundaries. So when it comes to the boundaries, it is the modified form of the limits. Therefore, when it comes to the upper limit, this is 10 and when it comes to the lower limit, this is 11. So we need to make a boundary for this, because all the values which lie between 10 and 11 are not considered in this case. Of course, if this is a problem of roll number, then I think we need not modify the boundary. But if this is a similar case of a problem where we need to calculate the height, if all the students weighing from 1 to 10, there are 5 number, then there might be some students who weigh even 10.2 kg or 10.5. So that the decimal representation comes only depending on the situation of the problem. Therefore, we need to consider even the data which lies between 10 and 11, 20 and 21, 30 and 31, etc. So that range from 10 to 11 would be missing here. So in this case of lower limit and upper limit, we need to fill the gap which lies between 10 and 11, 20 and 21, 30 and 31, and hence we need to consider the boundaries to even include the decimal values. So in this case, what I do is I take the boundary starting from, for the limits which are taken from 1 to 10, 11 to 20, 21 to 30 and 31 to 40, I define the boundaries starting with the middle of this. What is 10 plus 11 by 12? I just take the average of upper limit and lower limit by 2. So my upper limit plus lower limit by 2 taken an average for the first case would be 10 plus 11 by 2, which is 21 by 2, and hence 10.5. So this would be the upper boundary for the modified limit. So my upper boundary is taken as 10.5. Therefore, I start with 0.5. Assuming that because it's with equal range, I want to start with 0.5 to 10.5. Then my upper boundary here would be 20 plus 21 by 2, which is 20.5. And then here this would be 10.5. So the modified boundaries for the given limits are taken in the form 0.5 to 10.5, 10.5 to 20.5, then 20.5 to 30.5, and 30.5 to 40 or 40.5. So this is how the boundaries range for the given limits. Now, if I have a value which is 10.3, now where does this 10.3 lie? Where does this lie? So 10.3 is a value which clearly lies between 0.5 and 10.5. Therefore, this lies in the interval 1 to 10 or in the first interval. So indirectly, the boundary gives me the definition or makes an understanding that where should the decimal or the approximate value lies in each of the range. So 10.3 lies between 1 and 10, taken in the boundary form as 0.5 to 10.5. Similarly, if I have 10.5, then that is a tie between this and this. So generally 10.5 is assumed to lie between 11 and 20 because we take 10.5 with the next approximation, that is approximately equal to 11. So therefore 10.5 is assumed to lie between 11 or 20. Or there's nothing wrong if it is taken between 0.5 and 10.5. So as a rule, I take 10.5 lying in this range, and hence each of the limits are converted to each of the boundaries in this form. So note that the boundaries are also called true class limits. So the other name given for boundaries is true class limits. So this understanding of boundaries makes us understand that sometimes we need to convert the limits into boundaries because the boundaries accept all values in their ranges, but limits do have some filling gaps which need to be converted through boundaries, and that can be overcome by converting each of the limits or the ranges into the boundary ranges. The limit ranges into the boundary ranges is important because there might be some values which lie between 10 and 11 which also need to be included in the range. Now the definition is about class length. Now with the class length, the definition says that the difference between upper and lower boundary of a class is defined as the class length. So when we just found the boundaries in the previous case, let's take the same example as we have taken in the previous example, where my class length, which is generally denoted with C, is given by the difference between upper boundary minus lower boundary for each class. So in the previous case being with the first group where it was 10.5 minus 0.5. So in that case of an example, I get the class length as 10 with the formula being upper boundary minus lower boundary. So the subtraction from the lower boundary from the upper boundary gives me the value of the class length. So this makes me understand that the length of the class is with each 10 students, 10 observations, or any 10 counted in particular situations. So that is how the class length is defined. Now next, we're going to learn about how to construct a grouped frequency table. How do we construct a grouped frequency table? This is the question. A grouped frequency table. So the question here is finally, how do we construct a grouped frequency table or a grouped frequency distribution table? So the basic things required for constructing a group frequency distribution table is the class interval and the frequency. So sometimes when there are random scores given, we convert that into the class interval. But how do we convert that into a class interval? What length would you take for the class length? So the class length has already been discussed as the difference between upper and lower boundary of a class. The suitable class length has to be taken by considering the range, which we're going to discuss in the next session. So tally marks are already discussed in the previous sessions, so that should not be a big issue. So the group frequency table needs the essential factors of using the tally marks concept and finding the range of the entire distribution, and hence a group frequency distribution table can be constructed from the given scores. And let's see how we're going to do that in the session.